welcome to lab number 1, Chem 085. We're doing the lab of making aspirin. If you have a headache before this lab, at the end you'll have created something which you can take to hopefully ease the pain, right?
Yes.
Have you ever, from this lab, have you ever eaten the product? Have you ever tried it?
No, definitely not. You definitely shouldn't do that, actually, Jeff.
Why is that?
Well, the reason why is because when they make aspirin commercially, they do not use some of the accelerants that we use in order to get the crystals. And also, when they also make aspirin commercially, they would take the crystals and actually break them down and put them into a tablet-type form instead of having these sharp razor-like crystals go down your throat. So that would definitely ease one pain but create another, so to speak.
So you're telling me I can't eat it at the end? I was going to try that.
No, I would recommend not.
Advise not. All right.
Advise
okay.
not.
And you guys shouldn't do that either. So we're making today acetyl salicylic acid. Scott, our expert, is going to lead us through. We also have had Sherry, which isn't here. Did she help make some of this stuff?
Mm-hmm. Sure.
So Sherry, she wanted us to call her the official chemistry lab video stylist. So I wanted to make sure we got that on tape.
Perfect.
Okay, so tell us where we get started.
Well, before we get started with this lab, is you'll find at your station at the back of the room for Chem 85, you'll find there is jars of salicylic acid. Now, salicylic acid is a white, flaky powder, okay, and it does create a lot of dust when you're scooping it. And the one thing you definitely don't want to do with salicylic acid is you don't want to breathe it in through your lungs. It causes bleeding and things like that on the inside of your lungs, and I would consider that a bad thing.
So would I. Yeah, I'm not into that.
So salicylic acid, be very careful when you're measuring out your 27.5 grams. In this case, we've already pre-measured 27.5 grams into a 600 milliliter beaker, and it's ready to go. You just be careful when you're scooping it out that you don't breathe in the dust and you don't eat any of the salicylic acid.
So they can weigh this out over on the side there.
Oh, definitely.
That's where they can weigh it out. Just don't breathe it in.
Just don't breathe it in. Yeah, please don't breathe it in. And you do weigh it on the analytical balances we have on the side of the room, making sure that you use a weigh boat, of course, to weigh your salicylic acid. Now, everything else for this lab has to be done in one of the fume hoods. You will be using acetic anhydride, which you will notice smells an awful lot like very, very strong vinegar. Acetic anhydride, acetic acid is vinegar, okay? So you want to keep these fumes in the fume hood. You'll also be using 12 molar sulfuric acid, which is extremely concentrated. So please be extremely careful when you're using these dropper bottles as to not get any of this stuff on yourself. As you notice, Jeff and I are wearing polyethylene gloves and eyewear. Make sure you're wearing polyethylene gloves and eyewear. We also highly recommend that you find a lab coat or wear long sleeves for this lab.
Very good. I'm ready.
You ready to go?
Let's put some things together.
So, again, we have our 27.5 grams of salicylic acid in our 600 ml beaker. We're going to take our acetic anhydride and pour it over our salicylic acid. Now, acetic anhydride has very, very strong fumes. You want to make sure you're doing this as far in the fume hood as possible. You also want to make sure that you have the fume hood door down as far as you can while reaching underneath. Now, for video purposes, Jeff and I will take the risk of not having it all the way down, okay? However, you'll notice how deep we're keeping this in the fume hood. Now, it is important when you're using acetic anhydride that you have your instructor present while you're doing this, okay? So I know this seems maybe a little silly, but you're going to work in partners. It is already going to be pre-measured in a tube for you. And what you're going to do is you're going to wait for your instructor to come over. You're going to take it out of the test tube rack. You're going to uncork the acetic anhydride, pour it over the salicylic acid, recork it, and then put it back in the test tube rack. Okay? Once you're done that, you're going to take your gloves and you're going to take them off and throw them in the garbage. Because if acetic anhydride gets on your skin, it's a bad thing.
Oh, okay.
So, got my new pair of gloves. I have my acetic anhydride and my salicylic acid in my 600 ml beaker. Hands are sweaty.
They are very sweaty. These are quite warm.
You'll notice when you're using these gloves however cumbersome and awful they are to use, they will save your hands from chemical burns and loss of fingers. So make sure you're using them.
So now we have to throw 3 things in there, right? We have our salicylic acid, acetic anhydride.
And we're going to add to this mix, we're going to add 5 to 10 drops of sulfuric acid. I would personally use closer to 10 drops. It's just a catalyst to get the reaction going, so the more the better. And 12 molar sulfuric acid is exactly like it sounds, very concentrated. Now you'll notice that in each of your fume hoods there is a dissecting jar with this 12 molar sulfuric acid in it, with a piece of paper in the bottom. Okay, we want to keep this inside the dissecting jar. Okay?
Now we gotta mix that up.
Yeah, of course. Okay, so now what we're going to do is we're going to take a thermometer. Okay, you have a thermometer in your drawer. Take a thermometer and we're going to place this on a steam bath. The steam bath is this copper pot that we have in the fume hood. And Jeff is going to stir that for us for a couple minutes with the thermometer until it reaches about 80 degrees Celsius.
About 80.
Yeah,
We're about 20 something.
Between 80 and 85.
I stir it like this.
Exactly. Excuse me just for a sec.
Till it gets 80, eh?
Yeah, 80 degrees is where we want it.
Oh, it's up fairly warm already. 35. It cooks up pretty quick. How long is it going to take? Maybe 5 minutes?
5 or 10 minutes.
Cook up
It'll cook up fairly quickly.
I feel it's already getting very liquidy.
Yes, it will. It'll become an miscible solution, which means it'll be, well, infinitely miscible, you could call it. It'll become a as one, as we would say. It'll be as one.
It's mixed.
It'll mix,
together.
exactly.
All right.
So it'll take about 5 or 10 minutes till it reaches 80 or 90 degrees. Then what you're going to do is you're going to take that off of the steam bath and place it on the counter, and you're going to wait for 10 or 15 minutes. It's kind of like the BC ferries. You hurry up to get there and then you wait for half an hour. Okay, so 10 or 15 minutes, we're going to leave it in the fume hood for 10 or 15 minutes. Okay?
And thanks to our chemistry lab video stylist, we just happen to have some of that ready.
So we have it ready, and you'll notice when you get to this stage, this is very hard like a rock. Okay, so it'll be a hard hockey puck in the bottom of your beaker. Now I'm doing something very wrong right now. Can you tell me what it is?
I would probably say that I'm smelling something that I shouldn't smell.
Exactly. Okay, you don't want to take these out of your fume hood. You want to leave this in your fume hood, and in fact, you want to keep the fume hood down about halfway, just so that we don't, so everybody doesn't smell like vinegar when they leave here. Okay?
I sort of like the smell though.
Yeah, well, to each his own. Okay? Now, once you have this puck-like structure in the bottom of your beaker, what you're going to do is you're going to take a plastic spatula. Now, it's important that you use a plastic spatula. Okay?
Not a glass one?
Don't use a glass spatula for this. It makes sense, but some people do. Okay, and you want to break this up into bits. Okay? Lots of tiny little bits, and you want to make sure it is a fine sand, okay? Almost like a sand-like
So no
mix.
big pebble kind of things?
No big pebbles. We want sand, smooth sand, white sand in the bottom of your beaker.
So how long will that take me to keep banging
That will definitely take you about 10 or 15 minutes. Okay?
Oh, okay.
10 or 15 minutes to get it perfectly crushed up. Now, with that, you also want to make sure that you're starting from the outside and working your way towards the middle. If you start from the middle and work your way back out, it doesn't work.
Why is that?
Well, you get really big chunks if you start in the middle and work your way back out, and those chunks take a long time to go away. So you want to start at the outside and work your way towards the middle.
That's a good one. Outside
Okay.
in.
Outside in for breaking that stuff up.
I'm with you. Okay, so
Okay.
now that I've all got it as a powder, it's a perfect powder.
Okay, now, from there, okay, you want to add, while you're breaking this up actually, this is a good idea, just a little helpful hint. you're going to eventually want to add 200 mils of warm water to this solution. Okay, so while you're breaking this up, it's a really good idea to take your 200 milliliters of warm distilled water in a 250 ml beaker and warm it.
Oh, so you want to get
bath.
a little warmer than just tap warm?
Yeah, just a little warmer than tap warm. We don't want to use tap water in our experiment because of impurities, so if we want to use distilled, we're going to have to warm it somehow.
Oh,
and the steam bath provides an excellent way of warming your distilled water. So
do I need to measure temperature of that, or just get it like?
no, just has to be warm.
Right.
Just has to be warmed up.
Okay.
So while you're breaking this up, warm up your water. Put your water on in a 250 ml beaker and warm it up on the steam bath. Okay. Once you're done that, you're going to measure out in your 100 ml graduated cylinder. You're going to measure out exactly 70 mils. I believe it's 70 mils.
70 rings a bell to me.
Oh, sorry, 80 mils. Okay,
Or 80.
It says about 80 mils. We want to measure out exactly 80 mils, so we can change that in the lab manual. We want
change
exactly 80 mils of ethanol. Okay, you'll notice there's two big signs on the ethanol portion here. We're not in 1960 anymore where we can drink the ethanol. Not that we ever did. But
Not that you ever did.
this ethanol is both flammable and poisonous, okay? Denatured means that when you denature ethanol, it means that you've added something like phenol, a little bit of phenol or a little bit of benzene, I believe.
Oh, so it's not straight ethanol.
It's not straight ethanol. This is only about 95%. So you don't want to be drinking this stuff.
Oh.
And it's also very flammable, so you want to keep it away from the hot plate too. Okay, so when you pour in your ethanol,
Go.
again, we want exactly 80 mils. And that means that the meniscus is going to rest exactly on the 80 mil mark.
You're a little high.
A little high, but that's okay.
But you wouldn't pour that back into my ethanol beaker. I'd pour that into a different.
You pour that into the sink. Yes,
If you're a little high.
definitely.
All
Yeah.
right.
Okay. Now, with the ethanol, we are going to pour this 80 mils of ethanol into our sand, or what's left over of our acetylsalicylic acid, sulfuric acid, and our,
The salicylic,
our sulfuric acid.
sulfuric acid, and all that stuff.
Okay, and we're going to place it on the hot bath. And one thing you'll notice now, in order to do that, you're going to have to, of course, take off your 200 mils of distilled water, and you're going to want to start stirring. And you'll notice when this is on the steam bath, you'll notice right away that first of all, the little chunks will dissolve right away and go right into solution. The big chunks are going to take forever to go into solution. So you want to make sure you have as many little chunks as possible.
So break it down into powder.
Break it into powder is the best way to do it.
All right.
Okay?
Then we cook this for how long?
You cook that until it all dissolves.
Okay. Okay.
Okay, once it's all dissolved, we're going to add our 200 mils of our warm water
Yep.
into the solution, and it should end up looking something like this. So if we take that off,
I'll move this one off.
okay, we're going to end up with something on the steam bath that looks exactly like that.
Clear.
Very clear.
Doesn't look much like aspirin.
No, it really doesn't.
No.
Okay, it's a clear solution. It looks a lot like water. Doesn't smell like water.
Don't
though.
drink it.
Don't drink it. Okay? Once it becomes clear and everything's dissolved, you're going to take this off of your hot plate. Again, place it on your counter. Cover it with a watch glass. And wait for 30 minutes. Okay? Again, 30 minutes wait. It's really important that while you're waiting, that you wait for the entire 30 minutes. If you want to increase your yield of crystals, which we all, of course, want to do,
Oh, yeah. Yeah.
you're going to make an ice bath.
So for the 30 minutes?
For
Throw
the
it in
30
for
minutes,
30 minutes.
you're going to throw it into an ice bath. Now, the
Well,
way
this
you're
looks
going to,
like a little dangerous, doesn't it?
yeah, a little dangerous, but not so bad. Okay. Now, with your ice bath, basically what you're going to do is you're going to take a 1,000 ml beaker.
Do we have one of those in our drawers?
No, we don't. Actually, those will be on the side.
Okay.
Okay, so a 1,000 ml beaker, you're going to fill it about 200 mils with water, and then add ice. As soon as you've got the ice in there, you're going to put in your 600 ml beaker, so that it just rests something like that, and you're going to cover it up with a watch glass. Now, it's important at this stage not to stir.
Oh, no stirring now.
No stirring. Definitely no stirring. Now, the reason why is because if you stir, the crystals aren't going to come out of solution, and we want the crystals to come out of solution.
So I take it, I'm cooking it with my ethanol in it, put my water in it. As soon as I've got all that water stuff in and it's all clear, no, hold it. I put my water in after it's clear.
After it's clear, yeah.
So put the water in. Once I've done that, cold water bath, don't stir.
Don't stir. Leave it alone.
I'm with you.
And you'll notice that after your half an hour, you'll come back and you'll notice that you have these beautiful needle-like crystals formed. Okay, and of course Sherry has set this up for us already. So we already have basically a bucket full of needles.
So it went from clear to a bunch of needles.
Bunch of crystals, yeah.
All right.
It
says in the lab that sometimes you need to sort of start the crystal formation.
Yeah, sometimes you'll need to seed the solution. Now, when
And how would I do that?
you take a glass stir rod, and you just simply scratch the surface of the beaker. Sometimes crystals need a surface to start crystallizing on. So if you scratch the side of the beaker, it gives them a surface to start crystallizing, and you'll notice that right away, bang, you have crystals. It's quite amazing, actually. Hopefully that'll happen to somebody.
Yeah.
It's kind of cool. Anyways, as we were saying before, Sherry has already done this for us, so we do have our beautiful needle-like crystals already formed in the bottom of our beaker. Now the trick is how we're going to get them out of there. Okay? And actually we'll turn this off.
Sure.
And the way we're going to do that, there's a really easy way to get the crystals out of that beaker. And we're going to use something called vacuum filtration.
Oh.
Okay, so can we switch fume hoods here? We'll go over here. Okay, now you will, depending on the numbers in your lab, you'll probably have to do this vacuum filtration on your benches. Okay? Probably have to do it on your benches. It does smell a little bit, but it's nowhere near as bad as it is in the beginning. We're going to do it in the fume hood because it's just easier to do it this way. Now, in the fume hood, you'll know, or you're going to grab 2 pieces of hose. You're going to grab a number 4 filter paper. Okay,
where do we get that?
That'll be all on the side bench. Yep. Okay. Number 4 filter paper. You're going to grab a Buckner funnel, which is this white thing right here. You need the little O-ring for it. Okay. And a sidearm flask. And as you can see, it's got a sidearm to it. Okay, go figure. Sidearm flask has a sidearm.
I like your name for it. It's a good name.
Okay, now what you're going to do, make sure that when you put this O-ring on, that the flat surface is towards the sidearm flask and the curved surface is towards the Buckner funnel. Okay? This here is a trap. Okay, not a trap that you fall into, but a trap that we use so that nothing goes back into the vacuum. So you're going to place one end of the hose on the trap. Just figure out which one's the vacuum. Okay, one end of the hose goes on the trap, and one end of the hose goes into the vacuum.
So that's sucking air is what that's doing.
Exactly. Okay, the other hose goes to the other end of the trap, and then towards the funnel.
The sidearm.
The sidearm flask. Okay, so it sets up something like this. Now this trap, it doesn't matter if it's straight up and down, doesn't matter if it's on its side, it's a sealed trap, it'll be fine exactly like that. Okay, now with your crystals. Sorry guys, I know I'm right in the way. Your crystals are in a beaker. Now if you've left them for long enough, they will be fairly solid. Okay, they'll be solid in that beaker. So what you're going to do is you're going to take your spatula, your plastic stir rod, and just go around the outside of the crystals to release them from the side of the beaker. You might want to poke a little bit of the fluid through. Okay? And what you're going to do is simply pour all of the crystals into the funnel. Now Sherry's done a really good job here, so we should have an awful lot of crystals.
It does look very crystalline.
Just like a cooking show, hey? I feel like Martha Stewart.
Do you look like Martha Stewart?
Oh, some days. Okay, so now we've got our crystals all drying and forming. Now, what you want to do once they're in the Buckner funnel is you're going to leave these. Okay, you're going to leave them for at least 15 or 20 minutes in the Buchner funnel so they're going to dry. Now, the number 4 filter paper does a really good job at not letting the crystals fall through. However, sometimes what happens is not all the crystals have formed yet. So you will get some crystals forming in the bottom of your funnel. What you want to do is take the fluid from your funnel, put it in a beaker, and refilter it over your crystals again.
So if it stops dripping here, I can just put that over another beaker or something.
Yeah.
Pour this stuff into another beaker and then pour it back in.
Exactly. And actually a really good beaker to do that with would be the one we just took the crystals out of.
Yep.
Okay. So if there's any other questions, I think that's about it.
Those crystals look beautiful.
Well, thank you.
You sure I can't try some of that?
I'm positive.
All right. Okay. Well, anyway, so that is our video demonstration of creating acetylsalicylic acid, or aspirin. And so when you come to the lab, hopefully that'll give you a little bit better start on what we'll be doing in the lab. Thanks. Thanks,
All
Scott.
right, no problem.
Thanks to Sherry, our, what is it, chemistry
Stylist.
stylist. All right.